Maybe you want to buy a car in 5 years' time that is going to cost you 10 million, or you want to buy a house and you want to determine how much savings you ought to do every year to save the amount required for you to buy that asset. That is what we call deposits required to accumulate a future sum, and that is what I am addressing in this class. And it is normal in life that you have a project in the future that you want to do. It will cost some money, and maybe the bank has given you a facility that you can put your money in that account at a particular rate of interest for you to raise the money required for that project. So in that case, there is a future value that you want to achieve, and you want to achieve this future value by making some equal deposits into that account that is paying a particular rate of interest. So how do we tell the size of the deposit required annually? So that is what I want to address here. Let's use this example. We are saying John needs to accumulate 5 million at the end of 5 years to purchase a house. So the future value that he wants to accumulate is actually 5 million. That is the future value that he wants to accumulate. We are saying he can make deposits in an account that pays 10% interest compounded annually. So there is an account that is giving a rate of interest of 10% that you can make deposits, and this is being compounded annually. Then you are told how much should he deposit in his account annually for him to accumulate this future sum. So we are asking ourselves, what amount is this that is going to be deposited annually for a period of 5 years for it to grow to 5 million. Now, the, the future value of an annuity is equal to the amount times the future value interest factor of annuity at the rate of interest K in n periods. And the future value interest factor of annuity at the rate of interest K in n periods is calculated as 1 plus K raised to n minus 1 divided by K. And in this question, we have each of those requirements for us to calculate this. And a reminder that K in this case is a rate of interest, and N is the number of periods. So we are effectively saying here that 5 million, that is the amount that he wants to accumulate at the end of this period, is equal to the amount which we don't know. We multiply this by 1 plus K. The question tells us that the rate of interest is 10%. So 1 plus 0.1. The number of periods, we are told here that we will put this money in a deposit for 5 years. So that is 5 years. Then minus 1. Then divide this by 0.1. And you can actually make A the subject of the formula, and therefore say the amount is equal to 5 million divided by 1 plus K. Sorry, let me just use the whole figure the way it is. It is 1 plus 0.1. This is raised to 5. Then minus 1 divided by 0.1. So this will give us the amount that he has to invest each of those years for him to raise the amount he requires to buy that house. And we can then solve for this. So this is 1.1 raised to power 5, then minus 1, and then divided by 0.1. That is 6.1051. So it is 5 million divided by 6.1051. So his annual deposits into this account therefore has to be 5 million divided by 6.1051. That is 818,987. 818,987. That is what he has to deposit into this account annually if he is to raise the deposit or the cost of 5 million, the cost of the house, which is 5 million. And of course, this can be adjusted to any period, any rate of interest, even if the compounding is to be happening semi-annually or the compounding is to be happening quarterly. So this is how we determine what kind of what periodic deposit do we require for us to accumulate a particular future sum.